So here they say to us, a farmer has a piece of land in the shape of a right-angled triangle, OMN, as shown in the figure below. He allocates a rectangular piece of land, PTOR, to his daughter, giving her the freedom to choose P anywhere along the boundary MN. Allow the length of OM to be A and the length of ON to be B. And also allow the point P to have the variable coordinates X and Y. Because remember, P can be any point that is lying on the straight line MN, which is the boundary. Now the first question says, please determine an equation for a straight line MN in terms of A and B. Well, one thing we understand is, since MN is a straight line, we need to know two things in order to find its equation. We need to know the gradient, and we also need to know the y-intercept, all right? Well, the y-intercept is already given to us, having the coordinates 0 and b. In order to find the gradient, we need to use these 2 points, the point N as well as the point M. We can't use the point P to find the gradient because the coordinates of the point P are unknown. Are we fine with that? Of course we are. So well, in order to find the gradient of Mn, then we are going to take the y value at n, which is b, minus the y value at m, which is 0. And we divide this by the x value at n, which is 0, minus the x value at m, which is a. Now, in the numerator, b minus 0 is b. And in the denominator, 0 minus a is negative a. So I'm just going to put it there. So what? So now we can go to our slope point form. Well, we don't need to anyway, because here we can see that the y-intercept is b. So we can just say right away, y equals mx plus c. But of course, we understand that our m is b over a, and our c is just going to be the y-intercept. We don't need to calculate our c. It's already given to us on the graph. So that's the equation of this straight line, which is nice. Maybe we can cover it and say something like this to show that it's actually nice. Well, this one was relatively easy, so you didn't break a sweat in order to understand it. Now let's look at the next one. Well, here they say to us, prove that the daughter's land will have a maximum area if she chooses P at the midpoint of MN. Remember that the daughter's land is a rectangle. So what they're actually saying is, prove that the area of this rectangle will be a maximum at the point, which is actually the midpoint of the boundary MN. So what we need to do here is just to calculate the coordinates of the midpoint of MN. And then we are going to maximize the area of this rectangle and show what? Well, and show that the x coordinate of this point as well as its y coordinate will be exactly the same as the coordinates of the midpoint. Yeah, maybe it doesn't make sense when I say it, but You'll see it as I do it. Okay, fine. So let's begin by calculating the coordinates of the midpoint of the line MN. So we know that in order to find the coordinates of the midpoint, well, we are just going to take the x coordinate at n, which is 0, and we add it to the x coordinate at m, which is a, and we divide the whole thing by 2. Then we take the y coordinate at n, which is b. We add it to the y coordinate at m. And once again, we divide the result by 2. So this means the coordinates of the midpoint, which is the point P. Of course, if you like, you can just say P there because they told us that P is the midpoint, right? You can just say P. So you'll just say, well, 0 plus that, of course, it's going to give you that. So you have A over 2 for X, and you have B over 2 for Y. So these would be the coordinates of the point P. Maybe we can still keep that and do something like that. Okay, fine. So we have actually done half of the work. But now what we need to do is to show this in terms of derivatives, that the maximum area of this rectangle will actually be at this point. So the question is, how do we do that? Well, we need to begin by defining the area of the rectangle TORP, or maybe we can say PORT. Well, the area of a rectangle is length multiplied by the breadth. So what is the length of this rectangle? Well, it's OR. And what is the breadth? The breadth is actually the height. So you can either say OT or you can say RP. But it's actually better if you say RP. And this is what I want you to realize. What is the breadth of this thing? The breadth is actually the height, right? But the question is, what is the height? Well, I want you to look at the point N. Remember they told you that the length of ON is B units. In other words, the length of ON is exactly the same as the y coordinate of the point N. Do you see that? Now, similarly, the length of PR is exactly going to be the same as the y coordinate of the point P. But the question is, what is the y coordinate of the point P? Well, remember, the point P is any point that is lying on the function of Mn, right? And if it is any point, then it means the y coordinate at any point is defined by this equation. So what? Well, let's talk about the length of this rectangle, OR. What is the length of this rectangle? Well, we know that if this is a rectangle, it means PR is actually a vertical line. So if PR is a vertical line, it means the coordinates of the point R are actually X and 0. Because if it's a vertical line, it means the X value is the same for both of these. So this means the length of OR will be X units. So we take this X and we multiply it by the length of RP. which we said it's the y value on this straight line. And of course, we understand that any y value on this line is defined by this equation. So this means we have now expressed our area as a function of x. So what we need to do here is to distribute our x. So when we do, we get negative b over ax squared, and then we say plus bx. Then next, we need to differentiate our area function. So when we do, we get negative 2b over a x, and then we say plus b. Not sure what's the matter here, but we have to add b. And afterwards, we equate our derivative to 0. And then we want to solve for x, right? So we take this term to the left-hand side. When it gets to the left-hand side, it becomes positive. So we are now going to have 2b over a, which is equal to x. And in order to solve for x, we can either divide both sides by 2b over a, or we can multiply by the reciprocal, which is just going to be a over 2b, right? Yes, we can do that. Now, what is going to happen if we do that? Well, 2b and 2b will cancel out. A and a will cancel out. So on the left-hand side, we are left with an x. Then b and b will cancel out here. So on the right-hand side, we are left with a over 2. So this is the value of x that we get. Okay, fine. So now that we found our value of x, then we need to substitute it into the equation of a straight line so that we can get the corresponding y value. So we have negative b over a, and where we see x, we put a over 2, and we say plus b. Then what is going to happen? Well, sorry, I wanted to say a and a will cancel out. So we are actually left with negative b over 2 plus b. And if we say 1 minus half, well, we actually get a positive half. And of course, half b is exactly the same as b over 2. So what is the meaning of this? Well, here you can see that the maximum area is going to be at the point where x is a over 2 and y is a over 2. And if you give this point a good look, it's actually the point P. So now you can conclude and say, therefore, the maximum area of the daughter's land will be at the point, or maybe will be where P is the midpoint of the boundary MN. So that's all you had to do for this one. You had to find the midpoint of MN and then use optimization in order to find the coordinates of the point at which the area will be a maximum. And if they are the same, then you have proven exactly what they asked you to prove.